So in the 8-1 video, we were multiplying and dividing rational expressions. It's a little bit easier. Now we're going to be transitioning into adding and subtracting rational expressions, which is a little bit trickier, and that's because we have to find a common denominator if we're going to add, just like normal fractions. Okay, so to add or subtract, to have that unlike denominators, you must first find a common denominator. Okay, so in order to find, we either call it least common multiple or least common denominator. We have to factor them down. Factor them down completely, and then we can figure out how we can find the least common denominator. Because finding a common denominator would be easy. You just multiply them together. But we want it to be the smallest so that our work is easier. So for instance, if we were just adding these two fractions together, we would have to get a common denominator. And I'm sure you could probably just figure out what the least common multiple of 6 and 9 would be. It would be 18. 6 goes into 18, 9 goes into 18. It's the smallest thing that they both go into. But here's the process that you're technically doing. All right, so the 6 factors down into primes as 2 times 3. All right, and then 9 factors down into primes as 3 times 3. Okay, so I will walk you through the process that we're going to be using. So the least common multiple, when we say it that way, it has to be a multiple of 6, and it also has to be a multiple of 9. So the least common multiple, if it's going to be a multiple of 6, it definitely has to have a 2 times 3 in it. Otherwise, the 6 wouldn't divide into it. And if it's going to be a multiple of 9, it definitely has to have a 3 times 3 in it. Well, it already has a 3 in it, so we're just going to add in another 3. So now you can see it's a multiple of 6 because it has 2 times 3. It's a multiple of 9 because it has 3 times 3. So it's a multiple of both of them, but it's the least common multiple because we didn't use any more than we needed to use. So if we multiply these out, we get 18, which is in fact the least common multiple. So you can do the exact same thing with these. All right, with these, we can factor this one out. So we start with x times x to give us the x squared, and then we want to multiply to 2 and add to negative 3. So that would be a negative 2 and a negative 1. So in order to be a multiple of this, it has to have these two factors. Just like in order to be a multiple of 6, it had to have 2 times 3. So next one, the 2x squared minus 2. So we can start by factoring out a 2, and that'll leave us with an x squared minus 1. And then that'll factor down even further. All right, so it's got to have a 2, and then this factors to x minus 1, x plus 1. So my least common multiple has to have all of these factors, but without having overlaps. So if it's going to be a multiple of this, it has to have both of these pieces for sure. And then if it's going to be a multiple of this, it's got to have all 3 of these pieces. But note, I just don't want to include any overlaps. So it has to have a 2. So I'm going to multiply that in. Has to have an x minus 1, but I already have one. So if I threw in another one, it would be excessive. It wouldn't be the least common multiple. And then I need one of these, which I don't have yet, so I'm going to add it in. So this would be my least common multiple. So let's practice some of those with example 1. So least common multiple, when we're talking about these monomials, these are actually a little bit easier with like the A's and the B's and the C's. The numbers, we still have to factor them down. So let's start with the 15. So 15 breaks down to 3 times 5. That's broken down into prime numbers. 16 breaks down to 4 times 4. And each of those 4s breaks down into 2 times 2. 20 breaks down into 4 times 5. And the 4 breaks down to 2 times 2. Okay, so in order to be a multiple of 15 and 16 and 20, it has to contain a 3 and a 5, has to contain 4 copies of 2, and it has to contain 2 copies of 2 and a copy of 5. But in order for it to be the least, we don't want it to contain any more than it needs to. So my least common multiple, it's got to have a 3 and a 5. It's got to have 4 copies of 2. I don't have any copies of 2 yet, so I'm going to have to throw them all in there. And then it's going to have 2 copies of 2, which I'm good, and a 5, and I'm good on that. So if I multiplied any more of these in, it would be too big. And then let's look at A's. So I have to have at least 2 copies, none here, and I have to have at least 3 copies. So the least I could get away with would be 3 copies, because this one needs at least 3. Let's look at B's. This one needs 1, This one needs 5, and this one doesn't need any. So the least I could get away with would be 5. And then C's, this one needs 3, this one needs 2, this one needs 6. So the least I could get away with would be 6. Has to have at least as many as the largest one has. Okay, so now we can multiply this out. So this would be 15 times 16. Okay, so 15 times 16 would be 240. So this is 240, a cubed, b to the 5th, c to the 6th. That would be the smallest thing that all 3 of these terms would divide into and come out evenly. Okay, so that's with monomials. Let's take a look with polynomials. And we just did this on the front, but let's practice again. So this first one, we're going to factor it down. Notice all 3 of them have a copy of x, so we can start by factoring that out. So factor that out, and we'll be left with this. And then you always keep factoring until you can't factor anymore. So you've got this factor of x, and then the x squared, we can factor it down to x times x. And then the negative 2. We want to multiply to negative 2, but make sure we get a negative 1 in the middle. So that would be negative 2, positive 1. So that's the first one. And then we can factor this one down. So that next one, we start by factoring down x times x to give us the x squared. And then we want to multiply to positive 4, add to negative 4. So that would be a negative 2 and a negative 2. So I have to have all of these factors in my least common multiple, but without having repeats. Okay, so for my least common multiple, here's what I normally do. This is the way I think of it. I take everything from the first one, because you know it's got to have at least those factors. And then I look at the second one and see what I haven't included yet. So this one needs to have 2 copies of x minus 2. I already have 1, so I just need to add in a second one and I'll be good. Okay, so that would be my least common multiple. So those first ones, we were just practicing finding the least common multiple, so that hopefully these ones would be a little easier. So in example 2 and example 3, we're going to first find the least common multiple, and then we're going to go through the process of actually adding those 2 things together. So start with 6b and 14a squared b squared. We're going to start by finding the least common multiple. So for 6b, I can factor that down. So 6 factors to 2 times 3, and then I should have a single copy of b. 14, so 14 factors to 2 times 7, and then I have 2 copies of a and 2 copies of b. So my least common multiple, I need to have a 2 and a 3. This one needs to have a 2 and a 7. I already have a 2, so I just need to multiply in a 7. This one needs 1 copy of b. This one needs 2 copies of a, so I got to make sure I include that. This one needs 2 copies of b, so I don't need 3. 3 would be too many. This one needs 1, this one needs 2, so I'm good with 2. So that would be my least common multiple. So 2 times 3 is 6, times 7 is 42. Okay, so that's my least common multiple. So what I need to do now is convert this and this to have that same denominator. Okay, so I'm going to multiply in basically whatever is missing. So I'm going to start with the first term, 5a squared over 6b. So I need to get this denominator to be this. So I'm going to multiply in 6 times 7 would give me 42. And then I'm missing both the copies of a, and I'm missing 1 more copy of b. Okay, so you're going to multiply top and bottom by the exact same thing. We just call that a fancy one. And then plus, now here's the next denominator. Okay, this one already has the variables it needs. It's just missing that 3. So this one is actually a little easier. I just need to multiply top and bottom by 3. Okay, so this step, I'm converting them to have a common denominator. So I'm going to rewrite. So this numerator, 5 times 7 gives me 35. A squared times a squared, b, and then over my common denominator. Plus, these ones, 9 times 3 is 27, over my common denominator. So now, hopefully you can see I've gotten myself to a point where they have the exact same denominator, so now I'm good to just add the numerators together. So my numerators don't have like variable parts, so it's not like I can actually combine them. I would just write them like this over the common denominator. And that would be your final answer for something like example 2. Okay, I'm doing really similar things with example 3. I've got part A and part B. I just need to look at their denominators, first figure out what the LCD is, and then I can convert them and add them together just like this one. So first denominator, I have a 3x minus 15. So what I'm going to do with this one is I can factor out a 3. And factor out a 3, I'm left with an x minus 5. So my LCD needs to have a 3 and it needs to have an x minus 5. This one, I have 6x minus 30. So here I can factor out a 6. And then I'm left with x minus 5. So my least common multiple has to have an x minus 5. And then it has to be a multiple of 3 and a multiple of 6. Well, 6 is a multiple of 3 and 6. So this would be my least common multiple. So this one, as it turns out, already has the right LCD. Okay, so this one, I've got x plus 10 over 3x minus 15. All I have to do is multiply this one by 2, and I'll get it to have the same denominator as this one. So just multiply top and bottom by 2. The next piece already has the right LCD, so I'm good to just leave it. All right, so this, if I distribute the 2, I have 2x plus 20. And then this denominator is now 6x minus 30, so now they match. This subtraction part I need to be super, super careful with, because you want to make sure you're subtracting that whole thing. So like I have 2x minus 3x. That would give me a negative x. And then I have 20 minus 15. So that would give me 5. Okay, I'm actually going to write my denominator in factored form, and you'll see why. So I'm writing it like I wrote this. So now see, this piece in the numerator and this piece in the denominator, they're opposites. And remember, when these things are perfect opposites of each other, you can cancel them and you'd leave a negative 1 behind. So my final answer after all that just ends up being negative 1/6. Okay, so that's this. When I subtract this, I just end up with negative 1/6. Let's do one last one. I've got these polynomials here. So this one, my 4x squared plus 21x plus 5. This one's a little bit more complicated. I have a 4 in front. So I'm going to start by multiplying 4 times 5. And so with 4 times 5, I'll get 20. So remember, what I'm trying to do is multiply to 20 and add to 21. So that would be 20 times 1. So I'm in the process of factoring this one out. And I'm going to expand this middle term and then factor by grouping. So when I group this and group this one I have a GCF of 4x. And when I take out a 4x, I'll have an x plus 5. This one, my GCF would just be 1. And so I didn't really have to factor anything out. So remember the way grouping works. We treat this as one term, this is a second term. They both have an x plus 5. So I'm going to factor out an x plus 5, and when I do that, what I have left is a 4x plus 1. Okay, so this is the factored version of this. Now with this one, we can take out a 3. So 12x plus 3, I'm going to factor out a 3, and that'll leave me with 4x and then plus 1. Okay, so with this one, when I'm looking for my least common multiple, my least common denominator, I need to have both of these pieces. So I'm going to have an x plus 5, and I'm going to have a 4x plus 1. And to divide into this, I need to have both of these pieces. So I already have this one, but I need to make sure I have a 3 as well. So this would be my least common multiple. So my next goal is to make sure that these two pieces end up having this denominator. So when I'm doing these, because this is a little bit more complicated than this one, you should always be writing your denominator in factored form. So I'm going to keep an x minus 8, and I'm going to write my denominator as x plus 5, 4x plus 1. So then you see what you have and you see what you need. I already have these two pieces, I just need the 3. So I'm going to multiply top and bottom by 3. And then my next piece I have plus 6 over. Again, I'm going to write this in factored form. So now I know I have these two pieces, I need this one. So you're just multiplying in basically whatever is missing from that LCD. Okay, so when you multiply them out, they're all going to be identical. So I can multiply the 3 times the x minus 8 like that. In the intermediate step, I'm just going to write LCD. You can feel free to do that, just don't do it in your final answer. And then plus here, distribute that 6, so I'll have 6x plus 30. And then again, over my LCD, just make sure you don't do that in the final answer. So add these together. I have 9x, and then negative 24, I have plus 6. All right, and now for my final answer, I'm going to make sure I have the whole LCD. take a look at this last step to see if anything would be able to cancel. So one thing that I can do is there's a common 3 that I could factor out of this numerator, and I would have 3x plus 2. So then these 3's would be able to cancel. So I'd write my final answer as just the 3x plus 2, and then my denominator, I would have these 2 pieces that did not cancel. So my final answer would look like that.